for coming out and joining us. Just a little bit of housekeeping before we get underway. The toilets are out the door that you entered into the left. The emergency exits are at the back of the room on both sides. The meeting point is actually on Gordon Street, and Brian, our Chief Executive, is also our Civil Defence Controller, and we'll follow his lead in case of any emergency. Firstly, my apologies for the postponement of the previous meeting. It was organised quickly and to take advantage of having all the experts on site, and it was in an effort to keep everybody informed, and when those delays occurred it just made it too difficult for those working on the repair. So I do apologise that it was with the best of intentions of keeping everybody as up to date as we could. In the audience we have Councillor Kerry Sutherland, who's the Chair of Infrastructure, Climate Change and Emergency Management Committee, and he's just standing at the back. And next to him is Councillor Mike Long. We also have Councillor Erin Petty-Webber and Councillor Sharon Wards, who will both be on roving mics for the questions and answers following the team session. We have a special thanks to Councillor Steve Wallace, who's actually doing the sound for us this evening, so we really appreciate that. He is the Deputy Chair of Infrastructure, Climate Change and Emergency Management. Councillor Naomi Chase, Councillor Scott Gilmore and Councillor Peter Johns also join us here this evening, and all councillors will be around at the end of the evening if you want to share any further thoughts or questions with us. Our Chief Executive, Brian Nicholson, will introduce his team shortly. We've provided the past council papers on the table at the back, and there's some on the chairs at the front. That covers all the information and decisions that have been made up until now, and we can take any questions on those at the end. The team will talk about what the divers and experts saw, repaired, and then our next steps before opening up for question and answers. The slides that the team will share tonight, they'll go up on the website and be available for everyone tomorrow. We are recording this evening's meeting, just because it is difficult for people to get out in the evening, so that'll go up on the council's website. If anyone's got any issues with that, please see Nigel, our communications manager, at the back of the room. But it will just focus on the people at the front, the presentations. It will capture the questions. But if you have any issues, just let us know and we can work with that. And at the end, I'll just check in on communication and make sure if there's anything else that we can do to keep you informed. So Council's priority remains, first and foremost, the supply of essential water to town. Secondly, to plan and repair the Dannevirke Dam, which is also referred to as the Dannevirke Impounded Supply. Following, we'll have a review of lessons learned when the repair is complete. But some of those lessons are known already, and it's my preference to talk about these as we go rather than waiting until the very end. We know that the decision not to add the geotextile liner was an operational one. It wasn't deemed necessary as the base of the dam was prepared with clay, and this was deemed effective with the big heavy plastic liner which you'll see on display at the back of the room. It also shows the tiers that were repaired in that liner, so I highly recommend you just have a look and have a feel of how thick that is. The heavy-duty liner had very little ability to take the pressurised movement from underneath. The dam wall, where we refer to as the wet patch, has always been the most vulnerable, as it was the side of the dam that was built up. The new dam regulations, our own internal systems with project management, audit and risk systems, and committee structures all provide measures to look at all the elements of projects undertaken by Council. Our committee meetings are open to the public, and the project management reporting is available on the website, and the repair of the Dannevirke Impounded Supply will become one of these projects, so that'll be available for everyone to have a look at how that's tracking. I'm now going to hand over to Brian, who will introduce the Waters team.
Thank you, Mayor Tracy. Good evening and welcome to this public meeting. As Mayor Tracy mentioned, I am Brian Nicholson. I'm the Chief Executive for Tararua District Council. I would like to express my gratitude to you all for attending tonight's meeting. The primary focus of this meeting is to provide you with significant information regarding Dannevirke's impounded supply. For those who were present at last year's meeting, this will serve as an overview of the key activities that have taken place since then. As Mayor Tracy mentioned earlier, there are copies of the last report presented to the Council available at the back of the room, should you wish to refer to them. Tonight's presentations will include essential background information, an overview of the challenges we are facing, and an update on critical temporary repairs. Following the presentations, we will allocate time for questions to address any concerns or inquiries you may have. It is crucial to reiterate that our primary focus remains on working through various solutions to ensure a resilient water supply for Dannevirke, both now and into the future. I want to emphasise that these are complex engineering issues that require diligent work and expertises to achieve a positive outcome. Now, without further ado, let me introduce you to the team who will be presenting tonight. On my left, we have Chris Chapman, our Group Manager, Infrastructure. His role is responsible for overseeing Council's 3 waters, transport, facilities, our project management office, and solid waste activities. Chris has been with Tararua District Council since October 2020 and assumed his current role in March 2021. With his background in civil engineering and infrastructure asset management, Chris brings valuable experience working with councils and government agencies in New Zealand and Canada. He also managed the Tararua Alliance from 2017 to 2019. Next to Chris, we have Roger Earp, who currently holds 2 roles within the council. He serves as the Senior Program Manager for the impound supply and is also acting in the 3 waters management position. Prior to joining the council earlier this year, Roger dedicated 32 years of his career to the Army, serving both in New Zealand and overseas. His final 4 years were spent working for the Defence Force Estate and Infrastructure Department, where he held the rank of Lieutenant Colonel. Last but not least, we're privileged to have Julie Knackstein with us tonight. Julie is a Senior Water Resource and Geotechnical Engineer based in Auckland. She holds the position of Tonkin & Taylor's Business Leader for Dams and is on the Management Committee of the New Zealand Society on Large Dams. With over 18 years of international experience in geotechnical investigation, hydraulic design, dam safety management, stormwater design and coordination of multidisciplinary projects, Julie's expertise spans across flood management, irrigation, water supply, hydroelectric and road projects. So very privileged, as I said before, to have Julie here, so thank you. Once again, I extend my appreciation for your presence here tonight. I believe the insights shared by our team will provide valuable information and shed light on the ongoing efforts to address the challenges faced by Council's impounded supply. Thank you. I will now ask Roger to come forward. Thanks, Roger.
Thanks very much, Brian. Good evening, ladies and gentlemen. I'll just sort myself out. Good, it's going to work. Okay, what I'm going to do this evening is just take you through the repairs that have just been completed on the impounded supply and just give you some information so you have some understanding of what we've done and why we've done it. So in early May, we put in a remotely operated vehicle into the dam to assess the condition. We were concerned, obviously we had a high level of leakage and we wanted to know what was going on to help us make decisions about the future. And what that vehicle identified was 2 leaks, and you can see up here, this is a picture of one of them. Now you've got some, I know a lot of people have got the handout, you might find it's a little bit clearer on your handout than it is on the screen, so just whatever's easiest for you. Now what you see up on the screen here is the largest leak. So we found two tears in the liner. This was the largest tear, and it was about the size of a mobile phone, so about this size here. And then we found a second tear, which was essentially a pinhole. So I used the size of my thumbnail as an example. So very, very small, but quite clearly a tear in the liner. And both these tears existed in depressions. So the tear you can see on the screen at the moment was about 500 millimetres below the base of the level of the dam. And the pinhole was about 800 metres, so almost, 800 millimetres. So almost a metre below the level of what it should have been. Now, the remotely operated vehicle also found 3 other depressions. And Dewey will talk a little bit more about this and why they may have formed. Now the purpose of the temporary repairs was to stabilise the impounded supply. We were concerned of how badly the tears and the water that was leaking was undermining the impound supply, and we wanted to stabilise it. The goal that we set is that we wanted to reduce the seepage rate to 10 litres per second. So on average over the last few months we've been losing about 25 litres per second out of the impound supply, and we wanted to reduce that to 10. And we also wanted to stabilise the dam so that we could have time to do all the work that needs to be completed to conduct permanent repairs next summer. So not this year, but next year, 24-25. Now this shot here, and I suggest it's probably easier to look at your slide pack. You'll see that it's much more. But you do have that picture. My apologies, I didn't realise you didn't have the slide pack, but I believe you do have that picture. So I'm just going to talk about that picture now. So really that explains the situation up at the dam, the impounded supply when we were repairing it. So at any one time there are 19 staff up there supporting this operation. There were 4 divers and their support team of another 4 people. We had 2 consultants on site. We had Dewey with us right through the whole week, and also a representative from the manufacturer of the liner, the HDPE material that's at the back of the room. We had a number of staff monitoring the stability of the dam to protect the divers, so the divers, to allow the divers to focus on the job they had to do. The monitors were out there ensuring that the dam continued to be stable. We had a number of people managing the site, and then we had some plant operators on site as well. And you'll see, or you might be able to see from that picture, that there was some heavy plants. So we had an excavator, we had a loader, and we had some gravel on site that was there in case there were any sinkholes appear in the northeastern embankment of the dam or the southwestern. So we wanted to be able to react immediately to protect the integrity of the dam and also the residents downstream, down the Makirikiri stream. As part of our process, we advised the residents in a number of homes what we were doing so that they were aware, and we also had the police on standby in case we did have to evacuate people if the diving operation undermined the stability of the dam. You'll see some pictures on that page of the divers down at the bottom. Let's see if this is going to work. So this picture here is the divers just getting out of the impound supply, and you can see a picture here of the control centre, and we'll show you a video screen, a short video in a minute of that was created in that control centre.
Talk into the microphone. You can't hear you.
Sorry about that. Is that better? The picture here in the bottom left-hand corner is of one of our monitors just monitoring the water that was coming out of the dam during the repair operation. What I'm going to do now is I'm just going to show you a short video. Now this is what the divers found at the smaller of the two tears in the liner. So what you're going to see is the diver in the water. There's a bit of noise, there's a bit of background noise. You're going to hear the diver as he is examining this part of the impound and preparing to repair it. So this piece of material here is the bit that has been cut out. So you can see there's been a bit cut out up there. This was what was cut out. So when the remotely operated vehicle went into the dam, the hole was about the size of my thumbnail. When they actually got to it, this is what they found. So there was a number of holes. So the liner in about 6 weeks had deteriorated quite significantly in that one particular area.
That section there, was that over a chasm?
Yeah, it was over one of the depressions, that's correct, yeah. So obviously there was additional pressure on it. So that was shortly after the diver had cut this piece out, and they were just making an assessment as to exactly how they were going to proceed with the repairs. So what were the outcome of the repairs? They were pretty slow, to be honest. I don't know how many of you have a dive certificate or have done much diving, but anything that happens underwater takes about 2 or 3 times as long as it does above water, so it was pretty slow. We found that there had been, or we did not identify any deterioration to the eastern embankment, which was really encouraging. And we were able to reduce the seepage flow, or the loss of water from the dam, from 25 litres down to 5 litres per second. So we were really encouraged by that outcome. You can see that graph at the bottom, that's current to today, so it's stabilised at about 5 litres per second. Now we would expect to be losing water from the dam or from the subsoil drains all the time. That's what they're designed for. They're designed to capture any rain that comes under the dam, and then it enables it to flow out. So we would expect there to be probably between 2 to 4 litres per second coming out. And obviously we've had a lot of rain recently, so we've had quite a lot of water coming out. Now, what were the key findings? We found that the line was considerably in a worse condition than we had anticipated. The hole that was about this size was actually about 1 metre long by the time the divers got in the water. So there had been quite a bit of deterioration. There was a high risk that there will be more tears or leaks because the liner has been damaged in a number of places. We've identified that we need to do regular assessments, and we actually have another remotely operated vehicle in the dam next week. So they're going to come in and do an inspection of the repairs and the other depressions to make sure that there hasn't been any deterioration. And finally, the advice that we've received is that we cannot wait until the summer of 24-25 to repair it in terms of permanent repairs. We're going to need to do that much sooner. We're also continuing to monitor the dam, the condition of the dam. So we have someone up there every day checking the status of the embankment and how much water is being released through the seepage flows. And we're electronically monitoring that seepage flow as well. So that is a summary of the repairs of what we found and what we've done. Obviously we're very pleased to have reduced that seepage, but we need to continue to monitor it closely. What I'd like to do now is hand over to Dewey Napstein from Tonkin and Taylor, and she's going to speak in some detail around the impounded supply itself and outline why we believe that we have the problems with the impounded supply that we do. So I hand over to Dewey. Thanks, Dewey.
Thanks very much, Roger, and thank you for this chance to speak with you guys and also hear your voices later on. Tonkin and Taylor's been engaged to provide advice on dam safety and design of remediation at the dam. I'm aware that's only one part of the puzzle. There are other experts looking at water supply risks and all the wider sort of factors that go into decision making. So I'm going to talk about the dam safety issue and the mechanism we believe is occurring. And the first few slides I'll flick through will provide a bit of background needed to explain that mechanism. And lastly, I'll finish with options that we're looking at for long-term remediation at the impoundment. So the current slide that you're looking at, the key point to take away here is mostly the impoundment is formed by an excavation into natural ground. The part that is the dam is the part that's been built up, and that's shown in the green shading, both in the cross-section that's shown on the page as well as that plan view. And it's that built-up section that Tracy referred to. And that's the part that we're worried about as a true dam, is the part that's in fill. And in the next slides to come, I'll be referring to that as the Eastern Dam embankment. So this next slide, which is a little bit hard to see on screen, demonstrates a few different aspects of the design and construction. The impoundment has a liner system which is designed to provide water tightness, and that's made up of an HDPE membrane, a plastic membrane, over a layer of compacted clay. Below the liner system there is a drainage system, and that's made up of a network of subsoil drains. And those drains are spread across the entire floor of the impoundment and also partially up the side of some of the sides of the impoundment. Each subsoil drain is about 3.5 metres deep and 0.5 metre wide, and it comprises a subsoil pipe, so it's a plastic pipe with holes punched in it to let water enter, and it's surrounded by 40mm round drainage stone, and I'm going to talk a little bit more around that drainage stone in the coming slides. And it's backfilled, and then above that we have about 800mm of clay liner to top it out. The drainage system was originally intended to intercept groundwater rather than leakage from the dam. And the reason it was designed to intercept groundwater was to prevent uplift pressures on the liner system. But for a while it has actually been taking flows through gross leaks in the liner system. And that's obviously a much more onerous condition for it to be operating in, and not as it was designed. So that brings me to our current issue. Just for context, when dam engineers talk about dam safety and dam failures, what we're worried about is specifically an uncontrolled release from the impoundment. And the concerns are really around impacts downstream on people, the environment and infrastructure. And in this case, there's a very specific concern around the sudden loss of the reservoir itself in terms of water supply. The diagram that's shown on screen is our current hypothesis about a possible sequence of events that could plausibly lead to an uncontrolled release. Multiple steps have to occur all in combination in order for it to reach that stage of a failure. Some of those steps we know have already occurred, based on the measured subsoil flows, which are much higher than you'd expect, and based on the depressions you see in the reservoir floor and the damage that Roger showed to the HDPE liner. There is uncertainty about the likelihood and how quickly those remaining steps could occur, but we do know that there are vulnerabilities in the dam, and the under-drainage system is currently operating under hydraulic conditions it wasn't intended to or designed for. There are several vulnerabilities that we have identified at the dam. The main one is really an incompatibility between that 40mm drainage stone in the subsoil drains and the overlying clay liner, which is in direct contact. And there's also potentially incompatibility with the local sandstone into which the drainage, the subsoil drains are excavated in certain locations within the reservoir. And the mechanism we believe is occurring, and that seems to be borne out by all the observations that have been seen, is that the soil particles in that clay liner are being uplifted and washed through the 40mm drainage stone and under seepage and leakage flows. And that's what's leading to those depressions on the floor of the reservoir and the increased subsoil flows that are coming out the outlet. And it's also creating those voids or depressions. Basically, that video that you saw, you could see there were some large stones in them that were very angular, and essentially the clay liner has been completely washed away in those locations. It's disappeared through the subsoil network, which means that the HDPE is sitting under a tensile load with sort of 7 to 12 metres of water sitting above it, that it wasn't intended to be exposed to long term. It also means that some of those stones that were in the natural ground under the clay liner are now able to put point loads on that HDPE liner.
Can I just ask a question? Was there a geotextile cloth put on top of those stones before the clay was put in?
Can we just leave the questions to the end?
I think it's a period of at the moment though, just while you're going through those points. Yeah, it is.
Sorry, I couldn't quite hear your question.
Was there a geotextile cloth?
Thank you.
Was there a geotextile cloth put on top of the stone before the clay was put on top of that? To prevent the clay from washing through the stone?
There isn't a... We would often use a granular filter or a geotextile cloth in between. That would be current practice, and that's not in place. That wasn't in place originally.
Thank you.
So that's the key issue that we're concerned about. To provide a permanent long-term solution for the impoundment, we believe that that entire subsoil network needs to be remediated, and unfortunately that's below the floor of the reservoir. So to do that, we actually need to dewater the entire reservoir in order to do the repair. At present, there are constraints on being able to dewater because of the impacts on water supply, which Chris is going to talk to next. So at present, we do have a higher level of dam safety risk than people are willing to accept long-term, or that I would recommend long-term. And as a result, we are in a monitor and mitigate mode. So that means that we've got measures in place like operating the reservoir low, enhanced surveillance, and having an interim emergency action plan. So operating the reservoir low reduces that reliability of the water supply, but not as much as suddenly needing to dewater or losing the reservoir. That monitor and mitigation mode reflects a heightened level of watchfulness and readiness to respond, to detect the changes in the situation if they do deteriorate. The intent of that monitor and mitigation mode is to provide time to develop a solution without compromising the long-term fix and making sure that the community is left with the best asset long-term. We are in a situation where we are minimising and balancing risks to the extent practical. So that's weighing up dam safety and water supply risks and taking the overall lowest risk approach possible. So aside from the adverse behaviour that we've already talked about, I should note that there have been advances in dam engineering practice since the original design and construction. There have been changes in drinking water standards. There is upcoming changes in regulation and legal requirements around dam safety management that come into force next year. So there is a changing context and state of knowledge. So I'm now going to move on to talking about the options for a permanent solution. And there's multiple options still being considered. I'll talk mainly to option 1, which is the permanent remediation for the impoundment, which is within our scope. The other options are outside our scope, and Chris will talk to those after me. These other options, though, I should note, are not completely independent. Some of them are intended to reduce water supply risk during dewatering to undertake the remediation at the impoundment. Others also introduce the possibility of decommissioning rather than remediating the current impoundment. So there's a bit of detail on the screen at the moment. The full fix for the impoundment involves undertaking physical works needed to provide an acceptable long-term solution in terms of dam safety and water security. There are still unknowns and sub-options are still on the table. The decisions between those sub-options we expect will be governed by technical requirements as the uncertainties are resolved and the design process progresses. I'll take us through the different components of that full fix over the next few slides so that you can get a feel for what those look like. So perhaps the most important component is what we do with the reservoir liner and the subsoil upgrade. So all the sub-options we've got on the screen now involve remediating the subsoil drainage network. The first two involve ripping it out and replacing it. The third option is a build-over option, but based on the extent of damage that we've seen in these recent months, I think this build-over option is essentially ruled out by what we've seen. For all of the sub-options, the floating cover that's currently on the reservoir is removed, dewatering is needed, and earthworks will be required. Some materials brought from off-site, some materials sourced locally. There will be the existing HDPE liner that would need to be taken off-site to landfill and a new HDPE liner brought in. The type of impacts that you'd expect would be, aside from the water supply risks that Chris will speak to, would be your normal sorts of major civil engineering impacts like traffic movements, impacts of establishing new borrows, and erosion and sediment control type impacts. So we move on to the next component of the remedial works. The sub-options that are on screen now relate to modification of that eastern dam embankment, and they range from no change through to adding or strengthening the existing embankment by putting a stabilising berm on the downstream face, and the third option, which is fully rebuilding that dam embankment. The no change option is actually looking relatively favourable, but we need to do the detailed analysis and take that through peer review to get that confirmed. The downstream berm or strengthening option has some really significant advantages in that it can be constructed without dewatering and potentially as a separate project. So it doesn't have that same dewatering risk. That third option is really the one we don't want to go to if we don't have to, because it represents, so the full rebuild involves a major step up in earthworks, material coming from off-site, impacts on erosion and sediment control, and also the period for dewatering and the exposure to water supply risk during that period. So this brings me to my last slide on the components involved in the permanent repair as we're currently envisaging it. This is really a collection of rats and mice. All three of these elements would be expected to be included in the permanent solution rather than being alternative sub-options. While the reservoir is drawn down, there is an opportunity to upgrade the water supply outlets, reinforce the HDP liner at the inlet, and install dam safety surveillance instrumentation to bring the dam up to modern standards and take advantage of the dewatering to make sure that these aren't problems when dam safety regulation comes in the future. The works are relatively small compared with the ones we've spoken about on the previous slides. So I guess the last thoughts I'll leave you with is that progressing towards a permanent repair this summer is a relatively ambitious target. And it will likely require fast-track type approaches rather than conventional approaches. However, this would be our recommendation for dam safety based on the scale and the speed of deterioration we've seen in that May ROV inspection and in the recent repairs just 6 weeks later, as Roger said. So we do acknowledge that there are other factors than dam safety that need to be taken into consideration. So that's probably a good point for me to hand over to Chris to talk to some of those other factors.
Cool. Thanks, Dewey. So you've heard obviously from Roger and Dewey about the current situation with the dam, and whilst the objective for the repairs that were recently done were to try and push out any sort of permanent solution to the 24-25 summer, that's looking less and less likely. So that is forcing us to change tact, and I am conscious that really this has only become apparent a week and a half ago when the divers had finished their operation. So to take the impounded supply out of action, and forgive me if I'm telling you to suck eggs, because we have covered this off in the previous public meeting, but when we take the impounded supply out of action for what could be 3 to 6 months for these repairs to be done, takes away our buffer to provide Dannevirke with that reliable, safe water. When the Tamaki goes into flood flows and gets really dirty, that's where we use the impounded supply. When the river in drought goes to very low flows, that's where we use the impounded supply to top up what we are legally allowed to take out of the river, which is less than Dannevirke uses. So that's where we need to think about what we're going to do if this buffer, if the impounded supply is taken out of action. One of the big ones obviously is water treatment. So improving our water treatment plant to be able to treat that turbid or dirty water from the Tamaki River to a point where we can still send safe water that meets the New Zealand drinking water standards into town. We don't need to issue a boil water notice. So some works has already started in terms of the types of treatment technologies that are available, the suppliers. However, it has changed the game now that we're looking at before Christmas, ideally turn it on and everything's running point of view. So we do have some options that are being explored on that space. Water storage as well, and I know Dewey talked about the overarching options around what we do. Do we repair this the impounded supply or not? Would we be better off to decommission and build other storage somewhere else? Extremely high cost to do that, and we're still left with the land and the issue that is the impounded supply as it stands. People have talked a lot about tank farms, whether we can throw up some tank farms. To get any storage of significant volume becomes extremely expensive. Clip tanks are great for farms, but not good for municipal or local government town water supply networks, largely because they don't meet the earthquake standards. And other large tanks, steel tanks, we're highly unlikely now to have the time frame available to construct those at what would be an extremely high cost on a whole lot of land that we don't currently have. So treatment is looking more likely, as well as improvements to our water supply and demand. So we had been looking for alternate or ideally supplementary water sources. So a new water source, a surface tank or an underground tank that we could use to hook into the existing water treatment plant and it increase the volume of water that we have on hand. Investigations didn't find anything of significance, especially in a location that we could get to the existing water treatment plant up on Laws Road. So we have pivoted with that in mind, as well as the amount of time it takes to, I suppose, implement a new water take under the New Zealand drinking water standards and regulations. So we have pivoted and we're looking now for an alternate or supplementary source, specifically working with the Alliance Group, Meatworks. We know that if we can find something that supports them fully or partially, it's a win for council and it takes a fair bit of demand off the town water network. It's a win for the Alliance because it provides them with a lot more security and reliability of water, and it's a win for community because again there's lesser demand on the town network and we can implement that a lot faster if we can find a secure source. So work's going into that. As well as that, we really need to crack on with identifying and metering all of the connections between the source at Tamaki River Tap, the impounded supply and water treatment plant, and then the reservoir, the treated water reservoir at the back of Adelaide Road. So we know there's a lot of connections, historic connections that have never been metered, that we need to understand how much water is going through that and make sure they are set up as extraordinary users. It also gives us the opportunity to address the backflow prevention issues as well, especially on that treated water main between the water treatment plant and town. So just to make sure if there are any issues in the network, we're reducing that risk. One of the key considerations is obviously we're really looking into these options, what's feasible, how long will it take to establish and set up, how much will that de-risk the disruption on water supply, and then try and balance that. So a key question that our elected members, the Mayor and Councillors will be thinking of and what we'll be informing is what is that worth, I suppose, in monetary terms, how much will ratepayers fund to offset the risk, how big is the risk, and how much money will it take to de-risk it, and is it worth it? So looking ahead to this summer, so it is increasingly likely that the impounded supply will be emptied and taken offline for works to be done. So with that in mind, water restrictions, set in the scene now, extremely likely that there will be some form of water restrictions. Also, if we can't get the water treatment side sorted, boil water notices are a possibility. So we'll be looking obviously to do what we can to de-risk that, but that is a possibility. So if that's a big worry for you as residents, and we will be increasing the communications around this, is consider the timing of those high water use activities. If you've got things like swimming pools to fill up, houses to water blasts, all of those things that use a lot of water, and I think we said this around springtime last year, please look to do those before summer hits us, because when it does, who knows, take anyone's advice, but heard all sorts of things about what last summer was going to be, heard all sorts of stories that it was going to be a drought. I think it was the wettest we had in 50 years, but we don't know what that's going to look like, so I really strongly recommend if you need to use water, please do those jobs in spring. If you've got gardens, you're keen to keep going through the summer period, and in case we do have a drought and severe water restrictions, then consider getting water tanks. That's something that everyone can do to help with the resilience of their own property. Obviously leaks are a big one as well, so repairing leaks on your property and letting us know of any leaks on other people's property, or ideally leaks that are within our roads or footpaths that we need to get out and fix. In terms of next steps, there's obviously the ongoing monitoring, and Roger mentioned that we're getting a remotely operated underwater vehicle in there within the next week to again understand the risks and see how the patch repairs that have been completed are holding up, to see if there's been any deterioration around the other depressions. So while the divers were in the water, they did measure and mark up the depressions that weren't currently leaks. So through using our ROV, we can get footage of those just to see if there's been any movement, if there's been any deterioration, and quite easily to see based on the markings that have been done. We'll also be monitoring the subsoil flows, monitoring any signs of movement in the dam wall. There is obviously the further investigation of the options, what the scope of those looks like, what the costs of those look like, and then a report to council for them to make a decision. So at this stage we are looking to put a paper up to council for the Infrastructure Emergency Management Climate Change Committee on the 19th of July. Obviously once elected members resolve or ratify the option, we'll then have to plan, and staff will be planning and delivering on those options. That would be a huge amount of work in a very condensed time frame, as well as obviously be prepping for this coming summer and whatever that may look like. Now over to you. What do you want to know we haven't covered? Again, we've got elected members, Councillor Irina and Sharon at the back, roving with the microphones.
Thanks, Chris. So what we'll do is we'll alternate between sides. So Councillor Sharon, if you've got a question on this side, someone can raise their hand, and Councillor Dannevirke will be over this side.
Thank you. Any idea what happened first? Did the leak start and then the depression, or did the depression start and then the leak?
We've thought really hard about that, and I think there's plausible explanations for it happening either way at this stage. The damage that there's a lot of different ways it could have happened to start with. You know, like there could have been just speculating here, we haven't, you know, there's different possibilities either way. There could have been, you know, some mechanical damage during construction that led to a leak, and that might have created higher hydraulic gradients that then kicked off the process of internal erosion and washing away of the clay liner through the subsoil drains, and then that created depressions which then put more loads on the HDPE and other places, and then led to more tears. Or it could have started purely through groundwater or just minor normal leakage through a liner. So you can get, there is always some leakage through a liner system. So there are flows, and the amount of incompatibility in terms of the size of the 40mm round stone versus the clay liner that's directly against it is enough that relatively low gradients could potentially start off that mechanism. So it could potentially have started the other way around as well. But I think that they both accelerate each other. So the more damage you get to the liner and perforations through it, the faster the internal erosion mechanism happens. The faster the internal erosion mechanism happens, the faster the damage occurs to the liner at the top.
Thanks, Joey.
Just a reply, or I'll get a sense on this.
Just in reply to what you commented, so there's 800 millimetres of clay on top of those 40mm stone, correct? Yep. So because there was no geotextile cloth put on top of that stone allows for any of that clay to wash into the stone at any given area across that entire dam. Well, hold on, I need to carry on, but I only get one shot at this.
No, it's not that you can just get one shot.
No,
if you ask one question, it's so that everybody gets a turn.
Yeah, no, I just had another part to that question. So given the fact that if any of that clay could wash out through that stone because of no geotextile cloth, that would mean that the entire base of the dam would need to be redug up to put a cloth across those stones before the clay could be put back in. Because otherwise, anywhere across there, it could wash out. And in fact, at the moment, there could be great areas where there's no clay actually it's waiting to drop out now. Would that be right?
So the drainage stone is located in in basically a sort of fishbone sort of network of subsoil drains, and those are positioned at intervals across the full floor of the reservoir, and each of those is 1/2 metre wide. So you would end up with the contact area is sort of like a 1/2 metre strip, so it's not the full, they are spread across the full floor, but they're not continuous. So there's not, there's like spacing in between the different lines in the network. And so it starts at that, but then, you know, the clay liner has to be sucked sideways to enter the subsoil drains in between the spacing between them.
So essentially, I think Dewey mentioned that we're going to have to, one of the repair options is to dig up all those subsoil drains. They'll all need to replace, as you've indicated, and a geotextile material paste over them to ensure that doesn't happen again.
So therefore the only option you've got is your option 3 of those 3 options.
So we had 3 options for the reservoir liner and subsoil drains. 2 of those were full replacement of the subsoil drains. So that's all of it. The difference between the first 2 options is how much of the clay liner and HDPE liner is replaced. So option A was just a partial replacement of the HDPE and the clay liner over the top, just covering the bits that are above where the subsoil drains are and leaving the rest in place, whereas option B included just replacing all of the clay liner and all of the HDPE. And that HDPE comes in big strips, big panels that reach all the way to the top of the reservoir impoundment and all the way to the floor, and then there's a section, there's similar panels across the floor, so you can't easily replace just one part of it. If you're taking out a panel, you'll tend to take out the entire panel rather than fiddle around with patching, basically.
Thanks, Julie. Councillor Sharon.
Thank you. My name's Hamish McIntyre. My qualifications are only an architectural designer, but I had a lot to do with this dam right at the start with the soil testing with a well drilling business I was involved in. When we talked about the soils that were going to be put into this design and all that, there were certain things that were going to happen with the dam that had not happened. I'm going to say, this is a dead duck now, and you're talking about not considering the water farms, tank farms. I seriously believe we're getting it wrong. That dam, the land, we've got it. Use it. Get rid of that wall that is, in a sense, compromised. My other qualification is I was brought up on a farm where my father actually built dams and ponds. Not massive like this, but enough for me to know what happens with that wall. Your wall's compromised. Let's not try and fix it. Let's not try and fix this dam anymore. It's a dead duck. I've seen what the costs are going to be considerable in just maintenance, the whole thing.
Have you got a question?
Yeah, my question is, will the TEC now consider again, after many questions from the Ratepayer Association, will you please reconsider that tank supply? We've already done our research, so I don't know why yours is different, and I don't know why you think it's a cost that's going to be beyond repairing this. It's a lemon. You don't actually have to have a question, Sharon. It can be a statement.
Thanks.
Please, why are we not considering the tank farms?
Yeah,
you can actually put them in, so you've got a supply, so you don't have to worry about your impound supply. Once your impound supply is gone, you can still feed to a tank that's done to supply us. The Tamaki River, we will be well with under our resource consent take.
Do you want Chris to answer that?
Yeah.
If I can. So the tank farm, so you're talking about just decommissioning the impounded supply and putting tanks, building a tank farm on the same land.
You don't have to decommission it straight away. Put the tanks in first,
Okay.
then decommission, and
So
then
we
put
don't
another tank
have,
farm.
we don't have the land to build a tank
Yes,
farm.
you do,
We've got
on the
land.
impounded tank supply.
No, so yeah, so you're right. If it's going in exactly where the impounded supply is, we've got the land. So that would mean decommissioning the impounded supply to build the tank farm.
Not right away, just listen.
Well, it would, because
We've got
we don't
blue
have
gum,
land.
we've got blue gum.
Okay. Sorry, Hamish, I'm not going to enter into a debate.
No, I'm just giving you an idea, but you didn't even let me. No, listen, I'm going to say
If
one
you're not
point to the
listening, Hamish,
public.
then I'll just stop.
I'll say one public to the public. I wanted to get a man to do a bit of an investigation for there, and I invited you to do it, and you declined.
I told you I was away there.
No,
Hamish. I
there was
wasn't
a way, but you
available to
didn't
meet
take
you.
it.
We have already looked into tags. To build 120 megalitres would be a very large cost. To put them into the impounded supply location, we would have to take that offline, which presents the issues towards supply disruption. We'd have to look at. So we have looked at it, and we would need additional land to both to build or replace water storage while reducing disruption to town water. I appreciate where you're coming from, but it doesn't make sense.
Thanks. Councillor Aaron, have you got a question on this side?
Fuck, I'm gone, mate.
Is there anyone on the side with a question? You've got one? We're just going to hear and then we'll go to the
Okay. My name's Dave Bassett. I'm retired water and wastewater manager from Kapiti District Council.
You have to ask
what
for
legal
some resignation.
requirements do council have for supply of water to the meatworks?
Yeah, so on that one, obviously with the drinking water standards, New Zealand drinking water standards, we have water quality rules we need to meet, and that's where if we can't achieve those standards, that's when we have to issue a boil water notice, because we can't guarantee the disinfection, the lack of contaminants in that water. In terms of that supply of essential water to town, that's when we Tracy open. That is the highest priority. We want to make sure that town doesn't run out completely, so that essential water use will be provided.
But if you took the meatworks supply out, would that make it easier to maintain potable water to the community?
So that's certainly where we want to partner and work with the Lions Group on helping them find a supplementary water source. I think they probably cop a lot of criticism about the water use and the demand on town water, but there's a very good reason for that. They support our rural sector and provide large employment and economic benefits to Dannevirke, which I'm sure me and Tracy I want to touch on as well.
We're committed to working with the Alliance, and we meet with them regularly, and they have been fantastic. It's also a lot of jobs in our community, so it's just balancing the two. So the Chief Executive and I will meet with the Alliance next week as well, just to have those conversations. Okay. Councillor Sharon.
Thank you, Councillor Sharon. If you don't know me, I'm Ron Wallace, Community Board member, representing the people of Dannevirke. And I've been given 3 letters. This is the first one to you, to the committee up there, and I thank you for your reports and everything. And to the Mayor, this one, rear the dam. Are we going to be in the same position in 5 years' time, as I don't feel over the last 5 years we have accomplished anything but pay consultant fees? What we can say to that? And I've got 2 more letters I want to read out as well. Thank you.
So to that, I just say no, we won't be in this position in 5 years' time. And I guess if the writer of that letter was at the previous town meeting we had, and this one we've presented what we've done certainly since the first leaks back in 2021, and what the process was around that prior to 2021. I'm not aware of any leaks that were occurring at that time. So we're talking about the last 2 years.
So 5 years you're in the depot?
Yes.
Thank you.
Ron, I'll just go over to this side and then we'll come back. Is there anyone on this side with a question? We've got 2 more. I'll tell you what, I'm going to come over here. We'll do 1 more over this side, then we'll go to Brian, then we'll come back. Okay? Just to keep it fair.
Okay, here's the second one. The dam is beyond repair. We all know that. Councillors need to face up to the facts. They have suffered up, they had stuffed it up big time. We cannot go on paying consultants to tell us what we already know. We all make mistakes. This is a big one. Simple solution, rip it out and start again. Or you may see people power. Do it for you. We have had enough. You cannot expect our ratepayers to keep paying for this ongoing problem. Thank you.
Thanks, Ron. Whilst I understand the frustration in that, we can't just rip it out. Our main focus is to supply this town with water, so it's got to be done with all the care and safety to ensure that that happens.
Yeah, if I just jump in there, and maybe Julie would like to jump in. I think she's covered off those options in terms of what we need to do for the impounded supply quite nicely. I just want to touch on the consultant aspect. And I did intro the meeting, I introed Julie with the qualifications she has to advise us in terms of her experience with the dam. This is not about getting public opinion on what's best for the dam. It's about getting the right expertises, the right advice, and if we have to pay for that for the future benefit of this community, then I think that's money well spent. We can't be, I think it goes back to the previous question there, Ron, about do we want to be in the same place in 5 years' time than what we are now? The answer to that is no, we don't. Therefore, we need to get the people that know what they're doing to advise us on the appropriate fix for the dam. Let's be clear on that. This is a complex engineering issue and we need people with the right expertises to advise us on this.
Thank you. Councillor Erin, if I could just go to Brian, and then Councillor Sharon, we've just got just a check back from the ground there before I come to you. Is that right, Tony?
Up Bleedown Lane, where there is at present one reservoir tank, which I'm led to believe is very old, obviously, and not in starting condition. Now, is it in your future planning to put extra tanks up there, given the fact that we're reduced to one reservoir tank, and if that fails, actually we've got nothing for Dannevirke. Now, a question to you, and a question and a suggestion is, and I know there's issues over land, etc., right, so I know that that's got to be worked through. I also know there's a Public Works Act. But my belief is that I think, and I may be wrong, that there should be at least another 2 permanent, I'm not talking temporary, I'm talking permanent for the town, tanks up there to feed the town. Then the concrete existing one can be worked on. It hasn't been cleaned out in a long, long time. There are issues with the tank, as you would know, and I think that we need more tanks in that area that will directly feed the town. Is that part of the future proofing?
Yeah, it's a really good point, Brian, and yes, I suppose. So in terms of the existing treated water reservoir, so that has just recently had an assessment completed on it, and I believe some maintenance and repairs works are starting, about to commence. In terms of supplementary or additional storage, that was absolutely something we're looking at doing. I've always liked to use 3 days treated water storage. It would be a good amount to have. At the moment, we're sitting at about 18 hours, so doubling that or a bit more would be good. That was certainly something we're going to put up. However, in terms of reducing the risks on the town supply while the impounded supply is out of action, we won't get a suitably sized tank put up before this summer. I think that needs to be part of the long-term plan thinking, regardless of the impounded supply, that additional treated water storage. Something that I hadn't considered, to be fair, but something that does need to be considered is around the chlorination. So when you've got that amount of water sitting there stored, the residual chlorine levels in it do start to just deteriorate and drop. So adding in treatment processes at those treated water reservoirs would be a must. so we can continue to meet drinking water standards, and that obviously comes at not just the upfront capital cost to build those chlorine dosing units, but of the ongoing maintenance, servicing, refilling, all that kind of stuff. But yeah, additional treated water storage would be needed at some stage. Probably a matter of when, not if.
Yes. Just over here.
Then I would say then, the likes of the people up there need to be commended for actually progressing and doing something. But one of the things, the likes of the gentleman over there said about Alliance, you talk about essential water, therefore it's a matter of sharing the pain. And I don't think too much pain was shared last time.
If I could comment on that pain, so there were times where Chris and I both went out to the Alliance and actually said that we were nearing levels, we wanted to drop it again. They were always very obliging to do that. When we're talking about sharing the pain, that's where Chris talked about there's those others on that intake line. So yes, this time around there will be that sharing of pain, because yeah, it could hurt just depending on what that is. So they'll work with the Alliance first and foremost, but there are other large users that we'll need to make contact with. Okay. If I go to Chris and then Tony.
Yeah, Chris Southgate. The tank issue I think is very important, because 18 hours supply is minimal if there was a catastrophic failure of the dam. The dam site was acquired at great expense, but I believe the cost of additional land, either for more tanks or a bigger dam, is probably one of the least costs. My question is, if we had a shallower dam with a greater surface area, given that the depth of the dam was such that we have to pump the water out to get it, or the lower portion of the water out to get it into the tank, so there was clearly an issue with the levels. Would it not be feasible to increase the surface area of the existing impounded supply, given that the existing liner is at the end of its life and will have to be replaced? You've already told us the cover that's taken off could not be replaced, so that's a new cost. A greater surface area dam, the spoil from it boosting the eastern wall, which is the most vulnerable part of it. Is that a feasible option?
Interesting one, Chris. I don't think it would be feasible to modify the existing impounded supply to achieve that. I think it would have to be in a new location. Obviously, to do that would mean relining the entire thing. I think if it was with the intention of resolving the existing hydraulic and pumping issue out of the impounded supply, we already have a solution identified to that, to resolve that permanently, and I think it would be a more likely option, but certainly something we can consider over the coming days and weeks.
I think there's definitely, a range of different shapes and sizes that can potentially work, and there is just a cost benefit looking at whole of life cost. So looking at the upfront capital cost and the long-term pumping costs and practicalities, and also considering water quality implications of having a shallower reservoir, as well as more water landing on the reservoir as well that you then need to cope with in terms of the cover. Initial instincts are, if you have a shallower, wider reservoir, you tend to have more land taken up, more liner required, so you've got more vulnerabilities in that sense. But you've also got less water stored, which helps in other ways as well, and you do get rid of some of the pumping head as well. So there's basically a cost long-term whole-of-life cost exercise that would help you decide, which one's the best option.
Sharon, if we come to Tony, and then I've got a young man just in the back row.
Tony Rhodes. One of the issues in relation to the short-term position is in respect to the turbidity of the Tamaki and the issues that creates in terms of being able to draw. What consideration has been given to putting an additional gallery into the Tamaki River, trying to go deeper into the gravels and to try and rely on or achieve better filtration of the sediments whilst in turbid flow, and so that would allow you potentially to be able to take water through periods of turbidity for a greater period, and just reduce some of this non-availability period. So what do we know about the geology of the bed of the Tamaki in terms of the depth of the gravels and how much lower we could go?
Yeah, it's an interesting one, Tony. So investigation of the infiltration gallery, it hasn't been something we've considered at this stage. Probably far more feasible at this stage to put in temporary treatment improvements so we can deal with that turbid water from the Tamaki River when needed, as opposed to, I think, to be fair, looking at the current infiltration gallery, I have no idea how we'd rebuild that in the future with the new regulatory requirements and restrictions that we operate under now. But certainly something to be considered for long term, so something like a deeper well liners alongside the infiltration gallery instead of.
It could be done in conjunction with to replace it.
Yep, fair point. Add that to the list. Thanks, Nick.
Hello. Just a question for Juliet. Hi. Out of these 4 lovely options that we've been presented with your expert opinion, what is the best choice for Dannevirke moving forward? If you had to pick one, your opinion, not theirs, because you're the expert.
So I think you're talking about the 4 options that were on the slide, looking at the ones that are on there now. But I think they're the broader options. So we've been asked to look at remediation of the dam, so option 1. I haven't specifically looked into the other 3 options. So there was a decommission and build alternate storage, decommission and develop entirely new system, and there was an option 2, monitor and mitigation. So option 2, monitor and mitigation, I think we considered to give it due process, but ruled it out quite early because that basically involves continuing to live with the current situation, which is a heightened level of dam safety risk, operating at a lower reservoir level, and the associated water security risks of having only part of your storage available. So that was ruled out quite early on as, not a good long-term solution. I think remedy the impounded supply is a good solution in my opinion. I think that there are some definite issues. We have a confirmed dam safety deficiency to do with those subsoil drains. That's a real problem, and it does require major works to address it. But the dam embankment itself, you've already own the land, it's already in existing use, so the consenting and impacts of developing something new and the uncertainty around timeframes and disappears. Developing new storage new dams is incredibly challenging in the current environment, and I don't necessarily disagree with that, because there is an impact to developing and building a new dam, and if there isn't appetite for it, then it doesn't go ahead. But it does mean that the prospect, I can tell you as a dam engineering consultant how many potential options I've been asked to look at the concept design feasibility stage, but when it came through to consenting and actually building the thing, it just fell over. So it's incredibly uncertain whether you can consent and build a new dam. There's so many different barriers that can get in the way. And the existing dam embankment, while there are vulnerabilities associated with it, it also does have really flat batter slopes on it. I think we can do investigations to make sure that we understand whether that dam embankment is going to meet modern standards. And what we're talking about here is entirely replacing those subsoil drain networks, so fixing the problem. And we've got, I know I didn't want to defend consultants for costs, but I do, there is a lot of challenge and scrutiny. We have Tonkin and Taylor looking at this. I have an internal challenge team challenging me on things, and we also have an independent peer reviewer challenging it too. And I think that is warranted given the importance of the asset and the implications of getting it wrong. I think that there is ongoing scrutiny that will be on management of the dam going forward under the new regulations as well. So having that scrutiny now means that you're not going to have a problem in 5 years when a new consultant looks at it and goes, oh, actually I'm more conservative than the last group and I'm going to say it's not safe. So I think that scrutiny is valid. I know it comes at a cost.
So option 1?
Yeah, so I would say option 1, sorry, I lost track of there, and answered a different question. Option 2, monitor and mitigation, I think has been screened out very early on. Option 3, decommission. Option 4, decommission. I think the problems with those are really around timeframes for development. To consent to build a new system, you're sort of pushing timeframes for, you're not going to be able to decommission it this Christmas and build those things in time, basically. We just don't have time.
Thanks, Joan. Councillor Erina.
Thank you, Mayor Tracy. Terry Hines, Dannevirke Community Board. I'd like to ask a question for Dewey. What sort of guarantees do Tonkin and Taylor are they going to give the Tararua District Council that we're going to have a serviceable product at the end of maybe option 1, which is remedy the impounded supply? So that's the first part of the question. And I guess the other question, which is the elephant in the room, which hasn't been addressed yet, is that what is the ballpark figure that we're going to be looking at to do the remedy of the impounded supply? We know that it's going to be big dollars, but we need to know what it is going to be, and I guess we need to know how it's going to be funded. But of course that's going to be down the track. But if you could answer those, thank you, Jim.
So I think just starting with the last part of the question, in terms of costs, I understand that is still being looked at. So I think probably can't comment on that quite yet. In terms of guarantees and warranties, I've been told by legal experts that warranties and guarantees are not included, but what we do have is producer statements as designer, and then there are producer statements for the contractor and producer statements for supervision of the construction to make sure that it's done in accordance with the design intent and any changes during construction are appropriate. And we have, I think Tonkin and Taylor likes to stand behind our work. It's really important to us to fix things. People don't get things right all the time. But I think we I like to think that we stand behind what we do.
Yeah, I think it's important to be mindful, Terry. We're going to obviously have a prime contractor, an earthworks contractor involved in this process. We're going to need to have a company that provides the liner, the replacement liner. We're going to have companies providing monitoring equipment. So there's a multitude of companies that we're going to need to, or organisations that we're going to need to, I suppose, lock down who is actually responsible. But if I could say that the collaborative approach, at the moment we've had 4 or 5 different consultant groups working together that put together the temporary repairs in 4 weeks, and the collaborative approach in terms of getting the best outcome has been really encouraging. In terms of cost, there's been no detailed consideration of cost at this point, and the intent is that we'll be presenting costs to Council next month. That's what we're targeting to do. As long as we can have those, I suppose the rough order costs from the consultants, they're going to provide us with those figures as an indication to move forward. But we haven't looked at costs yet at this stage.
Thanks, Chris. I've got 2 questions in the queue and then I am going to wrap it up, but I would just say that, look, councillors are here until the end. So I've got the 2 questions on this side. I've got Chris and then Dot at the back.
Whatever my view there. I think that's so unfair. I'm here to represent the people that have asked me to read this out.
Yeah.
It doesn't go for very long.
You can always table that. I'm going to wrap it up at 8, so the quicker you stop talking and the next 2 questions get going, you're in with a chance.
You're on.
Go.
Yeah, hi, Chris Wood. Very interesting comment you made there, Dewey, about producer statements. Under the Building Act, producer statements are not a valid document in a court of law. So regardless of all these wonderful guarantees we get via a producer statement, it's not worth a ton of sticky stuff. Okay, so that one comment there. My original question was, from personally, I think the council have put together
real people that have real knowledge within our community, like historical knowledge of our area. What about them? They not have a voice? Absolutely.
Yeah, so on that, Dot, so I've met with various people who are keen to provide advice or thoughts. Absolutely, yeah. We've considered the option that was brought up earlier by Hamish, and it's not been deemed feasible against the other options.
754, wrong, you're right.
I think Tony can attest to the fact that we do go out with people and look at options if there is some local knowledge out there. And we do have locals involved. I was brought up in Dannevirke,
so was I.
To the team. Yep.
I've lived there all my life.
But I'm conscious that we don't have experts in dam engineering, and we need to rely on those people who do have those expertise. So that's why.
Where is Iwi in all this, please?
Sitting at the table. They have been working with the team.
Can I just comment? We invited iwi to our optioneering workshop, which we conducted last month. Unfortunately, both iwi didn't turn up, but they were both.
That is unfortunate. Thank you.
Yeah, not both of them. Yeah, sorry, one of the iwi wasn't able to make it, and I have asked on a number of occasions to have an opportunity to speak with iwi because I think it's critical they're part of this process.
Mayor Tracy, have I got time? Thank you.
Yes.
This is it, the last one I got sent to me. Why did it take so long to be made public? The dam. How many have been accountable for this? How many people have been accountable for this? Or has anyone, should I say, has anyone been accountable for this? Why is it taking so long to fix? What has it cost so far? What are the ongoing costs? The second to last point, how many qualified employees did or do we have that have been working on this? How many consultants have been employed, or is it left to local staff and employees working on it? Now that's just come from 3 letters that they've asked me to read out, and I'd like to thank all you people for the opportunity for doing that.
And remember, I'm Ron Wallace, the Community Board member. Cheers.
Thanks, Ron. There was a lot of questions in that. Do you want to attempt any of them?
Yeah, I think in a little time we're probably going to struggle to remember and answer all of them, right? I think in terms of when did we know about it and when was it first made public, we learned about it in July, chucked in the drones, did the inspections, and it was made very public since then. I think we've been pretty transparent in providing updates via Facebook, via council reports, via radio. We certainly haven't intended to hide anything away. It's just progress has been slow. And the situation has changed. We find out more and more. Even a week and a half ago, we found out new information that we didn't otherwise know, which does change the course of action we take. Honestly, I can't remember the other questions, so I think various have been answered in the past, but maybe we can respond afterwards.
Happy for you to leave those.
I could probably just quickly jump in terms of, I don't know what you mean by qualified, because I think in terms of qualified staff, we have very good experienced staff that are working on this project, that have fronted meetings, probably the second meeting, probably Roger's first one in terms of this, but that's exactly why we've sourced the expertise that we need, because the qualifications that we need to carry out this type of work is very limited throughout New Zealand. This is very complex, as I keep on saying, engineering, and Julie is, as me and Tracy said, one of 8 dam engineers in the country. Have I got that right? No, I haven't got it right. I'm going to let her get that right.
One of 8 qualified to do that.
I think there's a new system coming into play which has to do with recognised engineers, and so there's currently 8 in the country. There's a webinar tomorrow where I think we've got 200 attendees looking into getting that qualification. So I've got one of my most senior mentors as one of those 8, but I haven't had that chance yet. So I'll be one of those attentive engineers at the webinar tomorrow.
And Ron, if you give a copy of that council paper to the people that have written you the letter, there's a lot of information there that they'll like. Council, when they had that auctioneering exercise, actually the management allowed Councillor Kerry Sutherland to sit in there as well, so that he, as chair of the infrastructure committee, he heard everything that was there. With we're aiming to live stream as fast as we can. I think it's a little bit of everything, so we've got information on the website, we make all of those public, we're doing the newspaper, we're doing the Facebook, on Dannevirke Radio Friday at just after 11 o'clock. Myself and other members of the team are always there talking, so you're very welcome to leave a message with the chair of the Dannevirke Community Board, Pat Walsh, and we can attempt to answer those on air. So we're trying as many different forms of communication, because I think the more knowledge that everyone has, the less fear and uncertainty as we go forward with this. So we are trying our very best. So if you've got any other ideas on that, please let me know. And I'll have a talk to the team. They'll talk about tonight about the ROV inspections on a weekly basis, just how we communicate that to you so that you're as informed of any changes as we go along. So just in closing, I would like to acknowledge and thank Brian, Chris and Roger, and all of those that were involved from our waters team and those that worked during the repair. They worked dawn till dusk and even into the dark, and I didn't think you could work on the dam in the dark. And they worked right throughout the weekend to get that critical work carried out. I also learned that everything underwater takes about 3 times as long. And I was given the opportunity to watch the divers on camera and have a look at that operation. I was grateful for that. It was a very intense operation. A very special thank you to Joey, who was on the ground there through that whole process. We very much appreciate your knowledge and skills, and thank you for sharing with all of us tonight. Our team manage water every day. Their skills are in short supply and in high demand. And we're very grateful that we've got all of the team working with us. Thank you very much for joining us this evening. Myself and councillors will stay and make ourselves available if you've got other questions or you want to share any thoughts. The next key decision date is expected at the Infrastructure, Climate Change and Emergency Management Committee meeting on the 19th of July. So that's when the paper will go up around the different options. So that's a key meeting. If the options aren't finished on that date, we will actually call an extraordinary meeting and do that at full council at the end of the month. But the team are working towards the 19th of July. So when that agenda's out and will be available on the website prior to that meeting, and it's also open to the public to come and have a listen. The cost estimates will be shared as we've got those going forward in any decision-making papers as well. So I'll close with a karakia and wish everyone safe travels home. Kia tau te manaakitanga. Ki ronga, ki tēnā o tātou. Settle the care and protection upon each of us. Ki piki te ora, ki piki te māramatanga. May the health and understanding grow. Kia hoki pai atu, ki hoki pai mai. Return well to others and ourselves. Tūtura whakamaua, hold fast to your authenticity. Kia tīna, be firm, join together. Home ea, hui ea, taiki ea, gather, bind, join as one. Poe ea, and thank you for coming along tonight.